Okay. Today we're going to look at solutions. Solution problems are in your book on page 39. The problems we're going to be working are on page 39 in your workbook. Now, solutions, we actually worked solution problems on the first test. And to make a solution, we have to remember the formula strength desired divided by strength on hand is equal to amount on hand over amount desired. We did this formula on the first test, but you are going to have to memorize this formula. There's going to be quite a few solution problems on the last test. Strength desired over strength on hand, amount on hand over amount desired. Now the strengths, you can put a percent over a percent, or you can put a ratio over a ratio. But they have to be the same. If you have a percent on the top, you have to put a percent on the bottom. If you have a ratio on top, you have to put a ratio on bottom. The strength can be percent over percent or ratio over ratio, but they have to be the same. The amount desired down here, the answer has to be milliliters. The answer has to be milliliters. If you're going to mix up a solution, we're always going to mix it in milliliters. But the amount on hand, this answer here could be a gram or it could be a milliliter. Now, the reason the amount on hand can be a gram or it can be a milliliter, what we are mixing could be dry or it could start out wet. We could already have a 10% solution and we want to make it into a 5% solution. So if it's already wet, that amount on hand is milliliters. But if we're making a saline solution, we're going to start off with dry salt, so then the amount will be a gram. So it's got to be a milliliters on bottom. This has got to be a milliliters, but the top can be a gram or a milliliter. Now, sometimes the problem will ask you how many grams, or it will say how many milliliters. But if it doesn't ask how many grams or how many milliliters, anything that is pure is dry. Pure salt is dry until you drop it in water and make a saline solution. Pure acid is a crystal until you drop it and dissolve it and make it into a solution. But usually on acid, you already have a solution that maybe is a 50% and you want to dilute it to a 20%. So anything that is not pure is wet. And the reason we have to know this is sometimes we have to answer our answer grams, and sometimes we have to label it milliliters. If it was pure, it was grams. If it was not pure, it was milliliters. Okay, I'm going to do number one here, keeping this formula in mind. Prepare 1 liter of a 5% boric acid solution. I want to prepare a 5% solution. If they don't give me a strength on hand, we assume that it's pure. If the on hand is not given, it's pure. Pure, when you're working with a percent, is 100%. But if you're working with a ratio, pure is 1 over 1. So if the number on top would have been a ratio, this would have to be 1 over 1. But 5%, we assume that it's pure because they don't tell us. And I want to prepare 1 liter. If we cannot work with 1 liter, we have to change this to 1,000 milliliters. Now, does this go on top or bottom? Is this the amount on hand or desired? Now, another way to make sure you have these set up is check that the word of, numbers connected by of, have to be on the diagonal. And it said, prepare 1 liter of a 5%. 1 liter and 5 are on the diagonal. If you check your word of, you shouldn't get these upside down. So I put an X here. Cross multiply, I have 5,000 equals 100X, and I get 50. What am I going to label this? Grams or milliliters? Because if it was pure, boric acid comes in crystals when it's pure. Okay? Prepare 500 milliliters of a 1 to 50 strength from pure drug. Prepare 1 to 50. Pure drug is what as a ratio? 1 to 1. We can't put 100% if I don't have a percent on the top. So a ratio pure is 1 to 1. Prepare 500 milliliters. That's the amount desired, so it goes on bottom. Check your word of. 500 of 1 to 50. 500 of 1 to 50. So I'm going to take 1 over 50 times 500. But 1 over 1 is 1, so when I multiply it by x, I just get an x. 50 goes into there 10 times. Now again, this one on top can be grams or milliliters. So which one is it this time? Grams. Because it was pure. If it's pure, it was dry. Now sometimes on the test I will give you a little hint. I'll say how many grams or how many milliliters. Okay? Number 3 says how much 1/2 solution can be made from 2 grams of drug. 1/2%. How much 1/2 can be made from 2 grams? This is a percent, so if it's not given, what is pure?
100%.
This is a percent, so pure is 100. And it makes a difference, a big difference, whether you put 1 over 1 or 100. So if it's a percent, it has to be 100. I'm supposed to prepare how much can be made from 2 grams. If it's grams, this is the only place it can go. Grams can never go on the bottom. This has to be milliliters. 1/2 x equals 100 times 2. Now here I have to be careful with the division. You're dividing by the 1/2. Dividing by the 1/2 says to multiply times 2. 2. And it's 400 what? Milliliters. It's milliliters because that's the only thing you can have here is milliliters. Number 4 says prepare 1 liter of a 2% solution from a 40% solution. How much diluent is needed? Prepare 1 liter of a 2%. I want to, strength desired is 200, but what's the strength on hand? Prepare 2. So the strength desired is 2. But what's the strength on hand this time? Don't always slap 100% down there. We don't have 100% this time. Strength desired over strength on hand. I want to prepare 1 liter, so I want to prepare 1,000 milliliters. When there is a word of, number 3 didn't have an of. When there's 2 numbers connected by of, 1 liter of 2. If you'll check your of, you won't have these upside down. 1 liter of 2. So here I have 2,000 equals 40x Now, here the answer can be grams or milliliters, but what is it this time? It's milliliters because it's not pure. It's milliliters because it is not pure. If it's not pure, then whatever it is, whether it's salt or acid, it's already been dissolved in water. We're just changing the strength. If it's not pure, it's got to be milliliters. But now, this question asks something different. This question says, how much diluent? Diluent says, I'm going to start off with 50 milliliters, and I'm going to make 1,000 milliliters. Diluent is what you dilute it with. It's either water or alcohol, depending on what you're mixing up. But diluent says, if I'm going to start with 50 milliliters and end up with 1,000, how much diluent do I have to pour in there to dilute it? So I'd subtract my milliliters. Anytime they ask for diluent, or they might ask how much water, or they might ask how much alcohol. If they ask how much diluent, water, or alcohol, we always subtract the milliliters. Because what you're going to do is you're going to measure out 50 milliliters. You're going to add 950 milliliters of water until it is now diluted, and you have 1,000 milliliters. So because they ask diluent is another way to know it's milliliters, because whenever they ask for diluent, you take milliliter minus milliliter. And sometimes they'll say diluent, sometimes they'll say how much water. Then it's milliliter minus milliliter. Okay.
So the answer is what, 950?
Uh-huh. It's 950 milliliters of diluent. Okay, number 5. Number 5 says to prepare 1,000 milliliters of a 1-to-1 solution from tablets of 7.5 grain. How many tablets are needed? The tablet problems, when they ask how many tablets, whenever they ask how many tablets, we ignore that. We work the solution problem first. Work it as if it's a solution. Totally ignore the tablet. Once you get your answer to the solution, then you work the tablet problem. But we're going to have to work the solution problem, and then we're going to work the tablet problem. So number 5, the solution problem says prepare 1,000 of a 1-to-1 solution. We ignore the tablet altogether. We're not going to use that 7.5 grains on the first step. Prepare 1,000 milliliters of a 1:1. So what is the strength of a 1:1,000? What's the strength desired?
1,000.
So this time what is pure? 1/1. I'm supposed to prepare 1 liter, so I'm supposed to prepare how many milliliters? Look at the word of. Oh, it says 1,000 milliliters, didn't it? 1,000 milliliters of 1:1,000. Make sure your of is on the X, of is on the diagonal, and you won't get these upside down. So 1/1,000 times 1,000. 1 divided by 1 is 1, so when I multiply here, I just get an X and 1,000. But what is this answer? It's grams because it's pure, and it's also grams because they tell us we're going to find the tablets. The top can be grams or milliliters. If it's pure, it's grams. But also it's grams because we're going to have to work with tablets. But now we have 7.5 grains. 7.5 grains to grams. I'm going to tell you a conversion that we see so often, you're going to need to know this. 7.5 grains is 0.5 grams. And you would get that if you use the conversion that says 15 grains is 1 gram. But if you go to milligrams, you're going to get the wrong answer. But remember, if we want grains and grams, we use the 15 grains as 1. So 7.5 grains is 1/2 of a gram. You can convert it, or you can just always know that one. 7.5 grains is 0.5 grams. Now, this was the tablet, though. So we take 1 gram divided by 0.5 gram tablet. I converted this, but this was my tablet. 1 divided by 0.5 gives me what? 2 tablets. It says you would drop 2 tablets into 1,000 milliliters of water, and you would get a 1:1,000 solution. Number 6. Number 6 says to prepare 1,500 milliliters of a 1 to 500 solution from tablets of 7.5 grains. Just forget about the tablets for a minute. Prepare 1,500 milliliters of a 1 to 500. I want to make a 1 to 500. So what's the strength on hand? 1/1. Strength amount desired. Again, check your of. 1,500 of a 1 to 500. So I have 1/500 times, and 1/1 is 1, so 1 times x. Now, what do I get when I take 1,500 divided by 500? And 3 what? Grams. Now I've got to do the tablet part of the problem. I take 3 grams divided by 0.5 gram tablets. When I see that 7.5 grain, I'm just always going to put 0.5 gram. 7.5 grain is 0.5 grams. So 3 divided by 0.5 is what? And your answer now is tablets. It says, how many tablets do you put in here? Now, when we were giving people medicine, we didn't want to give them too many tablets. But on these problems, you might have 100 tablets. Because you're not giving this to a patient, you're simply dropping those into a bottle and adding water. So these can have a large number of tablets. Okay. Number 7. Number 7 says to prepare 500 milliliters of a 1 to 200. So I want to make a 1 to 200. I want to make 500 milliliters. But it says from a 2% solution. We cannot put a ratio here and 2% here. We can't mix a ratio and a percent. So we just have to know that percent means per 100. That's what percent means, is there's 100 cents, so this means per 100. So if you've got a fraction up here, if you have a ratio on top, you have to put a ratio on the bottom. Ratio over ratio. So first I'm going to have to take 1 over 200 times 500 and 2 over 100 times x. Now you can cancel this out and leave it 5 over 2. The reason I'm leaving it like this is I'm not through with the arithmetic. So I'm going to take 5 over 2 divided by 2 over 100. You have to divide by the number that's on x. So it's 5 over 2 times 100 over 2. Okay, what does this label have to be? It can be grams or milliliters, but was it pure? If it's not pure, it's already wet. Anything that's not pure is already in a solution form, so it has to be mils. Now on the test, sometimes I say how many grams and sometimes I say how many milliliters. But I don't always, so you have to know how to figure out when is it going to be grams, when is it going to be milliliters. Number 8. Prepare 500 milliliters of a 2%. Forget about the tablets. Prepare 500 milliliters of a 2%. 2%, if it's not given, what does it have to be on percents? Percents has to be 100. Prepare 500 milliliters. Again, always check your of. 500 of 2. 500 of 2 is on the x. So I multiply, I get 1,000. And what does this label need to be? This is grams because it was pure and because it's a tablet problem. If it's a tablet problem, it can't be something wet. Now I have to do the tablet part of the problem. We do the solution problem. Now we're going to do the tablet problem. And it says 10 grams divided by 0.5 gram tablet. Tablet has to go on bottom. So how many tablets? 20 tablets. Okay, prepare 2 gallons of physiologic salt solution. They tell you physiologic is 0.09%. This is the salt solution that you use to wash out eyes, to wash out wounds. 0.09% is what your tears are. Prepare 2 gallons. I cannot work in gallons. 1 gallon is how many milliliters? 4,000. So 2 gallons is 8,000 milliliters. You cannot work these in anything but milliliters. Prepare 2 gallons of 0.9%. If it's not given, what does this have to be? Again, check your of. This is 2 gallons. 2 gallons of 0.9. So 0.9. Get out my calculator today.
That's 7,200.
I'm sorry?
Never mind.
Oh, okay. Okay, so what does this answer have to be?
Yes.
Is salt in milliliters? But it's 100% right now. I'm going to make it, but what did it start out being? It started out being pure, so it started out being dry grams of salt. This says, how much salt do you put in water? And this top can be grams or milliliters. If this is pure, it's got to be grams. After we make it, it will be milliliters. But right now, the salt is dry. One thing you'll need to watch for this homework is 1 pint is how many milliliters? 1 quart is how many? And 1 gallon we just did is 4,000. Because some of these problems will have pints, quarts, you always have to work to milliliters. The homework will be 40 through 43. I've got a quiz scheduled for next time, but instead of a quiz, we're going to work the problems together. And that way you'll have it to take home with you to study for the test. So, but do work these problems. You just work 1 or 2 of these problems, you're not going to get solutions. Spend some time and make sure you work all of these solution problems. We don't have a quiz Monday. We'll go over it together in class. Okay. We'll see you next week. Is that easier to read up here? For the back especially.